We're going to approximate a root of f of x equals x cubed minus 3x plus 1 in the interval 1 to 2. Now we're going to go ahead and take that the first value, our initial point, is x naught equals 2. Alright, so let's go ahead and find x1. x1 equals, based on our formula, that will be x0 minus f of x0 divided by f prime of x0. Now that is 2 minus f of 2. Alright, now I'm going to go ahead and use, just spit these values out very quickly, minus 3x plus 1, and that will be 3x squared minus 3. Alright, so of 2, that will be 3. Alright, now f prime at that same point is 9. So that should be, that's 1/3, 5/3. Okay, next, x2. Go ahead and plug in the things I know here. That'll be 5/3 minus f of 5/3 divided by f prime of 5/3. Alright, f of 5/3 is 17/27. And then we'll find f prime of 5/3, which is 16/3. So that 5/3 minus 17/27 divided by 16/3 is 223/4 or 144. Alright, a couple more iterations on this. x3 is 223/144 minus f of 223 divided by 144 divided by f prime of 223/144. So the work here is not hard, it's just tedious. Minus f of 223 divided by 144 divided by f prime of 223 divided by 144. And that does not have a good approximation of fractions, so 1.532390162. Right. Now these values do not have, we don't have to use all the decimal places. However, for the most accuracy, we want to use those. F of x4, 1.532390162 minus f of 1.532390162 divided by f prime of 1.532390162. Now it's a good idea to use storing a variable function in a calculator, which is what I am doing. So I'm calling that long value a. So a minus f of a divided by f prime of a. And that is 1.532.320.889. Now if you notice, these values are getting closer to a value. 1.532.532.088.989 minus f of 1.532.088.989 divided by f prime of 1.532.088.989. Alright, store that as another value. A minus f of a divided by f prime of a, and that is 1.532.088.86. Yes. So our x1 through 5 are these values. Now they appear to be approaching 1.53 something. Okay. Which tells us that we likely have a solution. If we continue this iteration for a few more steps, we might see what a 0 actually is for that function. Right, next, we want to use Newton's method to approximate square root of 2. Now let f of x equal x squared minus 2. And we're going to choose x naught to be equal to 2 and calculate x1, x2, x3, x4, and x5. Since the function f of x has a 0 at square root of 2, the initial value of x equals 2, or of x naught equals 2, is a reasonable choice to approximate this. So we'll go ahead and state x naught equals 2. x1 will be 2, okay, f of x naught minus f of x naught, in this case 2, divided by f prime of x naught. I'm going to input those functions here, x squared minus 2. Now the derivative is 2x. Alright, so 2 minus f of 2 divided by f prime of 2 is 1.5. Alright, for x2, we'll take 1.5 minus f of 1.5 over f prime of 1.5. Alright. Now for our first function, evaluating that at 1.5, dividing by our derivative at 1.5, that is, as a fraction, 17 over 12, or 1.416 repeating. Alright, next we'll have 17 twelfths minus f of 17 twelfths divided by f prime of 17 twelfths. Okay, that is 1.414215,686. Now the square root of 2 is 1.414 and some change. So it looks like we're close. 4215,686 minus f of 1.41425,215,686 divided by f prime 1.414215686. And then that is 1.414213562. And x5, skip a step there, that is 1.414215, no, 1.414213562. And that is the same value, which is good. Okay, so we are approaching the value of the square root of 2, which square root of 2 is exactly well, I say exactly, according to a calculator, 1.414213,562. So Newton's method works very well to approach a root pretty quickly. It only takes these 5 steps to get there.